interesting and important chapter today. We will talk about how to create 2D and 3D plotting, how to do handling graphics in MATLAB, how to do animation, and eventually how to save and export the data or the graphs using MATLAB. Now, for the basic 2D graphs, we did a lot of plotting in the past as an introduction to how to do 2D graphs in MATLAB. Basically, the main function for plotting is plot. So you do plot x, plot y. You have a script there that's saying x equals this, y equals that as an arrays, and plot xy. So you can do plot xy, then he's going to show you the xy on MATLAB. Of course, we took this example before, x equals 0 to 4 pi with an increment of pi over 4. When you do plot x, he's going to plot x, comma, sine x. It's like you're saying plot x and y. So always in plotting or in mathematics, to draw something, you need 2 points. So in this case, you're taking the value of x, then taking the value of sine of x at that exact point. That's going to generate a graph for you. Or you can do plotting similar to this way, like 0 to 4 and 1 to 3. And eventually, there is the command that we talked about before called easy plot. So when you say easy plot sine of x, MATLAB will recognize the function sine of x, and you will be able to plot your graph as needed. X equals, open parentheses, 1 to 4. What we're doing here, 1 to 5. We are creating an array, 1, 2, 3, 4, 5, right? Then y equals 6 to 10. Close parentheses, then you say plot x and y, x comma y. That's going to plot x and y for you, which is linear in this case. Now, graphs can be labeled as using the statement gText, open parentheses, open quotation text, and close quotation and parentheses. Of course, we did graphs before, and we are able to do x and y axis labels for the graphs. Now we will scan through some of the tools that you can use to create some labels on your graph. Labels mean the things that you mark your graph. You can mark the x-axis of, you can call it x, you can call it x-axis, you can call it temperature, and your y-axis, the same thing, you can call it whatever you want. You can have a headline for the graph and so on. Now there is kind of side functions that you can use, like the grid, that will add or remove the grid lines or the square lines on your graph. And you have as well text, open parentheses, x, y text, that will write text into the graphics window at the point that you specify as x and y in your screen. And we have as well title, open parentheses, open quotation text, that will help you to put a title for the graph. And x label horizontal will label the x-axis for you. Y label vertical will label the y-axis for you. And remember, here we're talking about 2D graphs. Today we're going to learn how to do 2D graphs and 3D graphs. So far, those are used for the 2D graphs. Now, if you have multiple plots, then you can draw the first plot and the next plot by having the command hold. That's one way. The second way, you can say plot. Let's say I said x1 equals 1 to 4, y1 equals 2 to 5, then x2 equals 10 to 20, y2 equals 30 to 40. Then you can have plot x1, comma, y1, comma, x2, comma, y2. This way you'll be able to draw the x1, y1 graph and the x2, y2 graph all together. And again, we learned how to use hold. You can say plot x1, y1, then hold, then you say plot x2, y2. He's going to plot them both on the same Cartesian. The third way is just use plot xy, and sometimes you need to have another y-axis, like right-hand side y-axis and left-hand side. That you're going to use by using plot yy. Now, if you have x and y, then you have plot xy, we know that. But if you say, if you have this one as x1 and this one as y1, then you create x2 to equal, so another vector. Let's try to keep them all the same size. So 1, 2, 5, 6 to 10. Try to have them the same array size. Now x2 should be what? 11 to 15. 2 is comma, not a dash. Semicolon here. Then y2 equals 16 to 20, semicolon. Now if you plot x1, then y1, then comma x2, then y2, and make sure if you capitalize or not. Let's try that together. So if you run it, what's going to happen? Add to path. So here we have a comma instead of column. Okay. Now let's run it. Now you can see the blue is representing x1, y1, and the red is representing x2, y2. Of course, in this case, because the way I put the values, they are disconnected between 10 to 15, I believe. But if you draw both lines starting from the same origin, like one line start from 0 all the way to 10, the other one 0 to 20, you're going to see two lines in a healthy way. But that's just to demonstrate for you how does the plot of two lines happen. If we comment this out, and we have what? Using hold. So you identified your x1, and if I click on this, it will uncomment, by the way, all at one shot. So x1 is this, x2 is this, y2 is that. Plot x1, y1, then hold, plot x2, y2. If you run it, what's going to happen? If you run it, then you're going to get the same result as discussed before. Now, of course, we said using the title and x label, y label. Of course, that's something I'm going to ask you about in the exam. So notice here, when we created this script, I'm uncommenting here. So you identified your x1, y1, x2, y2, then you plot them all. Now you say after the function plot, you say title is, you can call the title whatever you want. And then you write x label, between the quotation you write whatever you want, y label, between quotation write whatever you want. The title will be in the center top of the graph. X label will be centered to the x-axis, y label will be centered to y-axis, as long as we are graphing in 2D. Let's try that, and I suggest for you either you find the script and run it and play with it, or you rewrite it, whatever works for you. Let's do that. Now when you run it, you can see here we had the title to have XY data plot, and you have the y-axis here, x-axis here. Now I can change that and say it's XYZ here, and with space, whatever I want inside the quotation, YXZ. Then if you run it again, that's going to give you, see, so those x-axis label, y-axis label, and the title is here. So the textbook is giving you plot YY. So in this case, you can put, instead of having plot x1, y1, x2, y2, you can as well define the x values, then have x sine of x for the first graph, x 10 cosine of x, the second graph. Generate the title, and generate the x label and the y label. Now in this case, you can see if you want to have something more mathematic, like you have two curvy graphs that are side by side. One of them is automatically selected by MATLAB to be red, the other one is blue. Of course, as moving forward, we're going to learn how to control those colors if we want to. So there's unlimited possibilities to do that. Now about the G text, we talk about it in the slides, but we didn't do it actually. What's going to happen when you have the G text? So let's say we have here x and y values. Where is it, the basic plot? Yeah, here. Then you tell him G text, open parentheses, open quotation text. What's going to happen? Now in this case, MATLAB will give you kind of arrow. You can put the word text wherever you want on the graph and even off the graph, like on the axis, anywhere you want. When I click, he's going to show the word text. Of course, that can be changed. You can, if you are graphing some data, then you can say, this is the critical point, or so and so. You understand how the scientific writing or graphing happens. Sometimes you got to call out things. If you want to do it in a programmatic way, then you can do it this way, using the function gtext. Now for the line styles, markers, and colors, now if you say plot, we learned how to say plot x comma y. If you say plot x comma y comma between single quotations, two dashes. In this case, he's going to use dashes format to draw your graph. Try that, and if you replace the two dashes with O, then he's going to use O as the pen, if you will, to draw the graphs. Let's go ahead and try that together. Plot x1, y1, between quotations, give it two dashes, if you call those as dashes. Now, if I run it, you see the line is not solid anymore. It's made out of dashes or dotted line. Now, if I change the dashes into O and you run it, then in this case, he's going to use O's in order to draw the graph or the line or the curve, whatever you call it. If you want a certain line to behave differently than the other line, so here we have two lines. We have solid one and dotted one. What I'm going to do, when I write the command plot, I say plot x1, y1. By default, it's going to be a solid line, so it's a solid line. Now, then I say x2, y2, which is this guy. I want to be dotted, then comma. Between single quotations, I give it two dashes. In this case, he's going to plot the first one for you as a solid, the second one as dotted. What if I want the first one to be in a format of O's? Then I can say plot x1, y1, then between single quotations O, then x2, y2, between single quotations, two dots. This way you'll be able to draw your graph in this way. Now you can see here, if I plot dashes, if I plot O's, we already learned that. Now if I say plot x, y, OM, then two dashes after that, run it. You see the color here. Okay, how about if I say OR, which is referred to red, then you got your color in red. If you don't want those O's showing up in the graph, just remove the O, run the editor, then you get a solid or a dotted red line. If you try blue, let's have B, then you run it again, then now your color is blue. If you want it to be yellow, just put Y before your preferred way of drawing the graph, which is dotted in this case. Then you're going to see your yellow, even though it's barely visible. Now, if I have two graphs, I want one of them to be dotted red. The other one is dotted, let's say, yellow or green. Then what I'm going to do, I'm going to plot x, comma, sine x. That's for the first, like x versus sine x. That's going to have O's in red with dotted line. And the x versus cosine x, he's going to have green with dotted lines only. Run it. You can see the first function is red dotted lines with O's. Second one is green dotted lines. So now we know how to draw two lines, how to change each line color. And we know as well, if you want it to be dotted, you want it to be in O's format, you guys should be able to do that already. Now, the axis limit, sometimes you draw a line. Let's say one of them is going on the x-axis from 1 to 10, on the y-axis from 1 to 5, or let's say from 1 to 30. Then you're going to limit that to be 1 to 10 on x-axis, 1 to 10 on the y-axis. Then that's where the function axis is helpful. Function axis general format is axis, open parentheses, open brackets, x minimum. So you put the minimum value for x, you could say 0. Comma, x max, so you could say here 10. Then the y minimum should be maybe 0 in this case. Y max should be 10. Then in this case, you limit the graph, which was on the x-axis 0 to 10, on the y-axis 0 to 30, to be 0 to 10 on each axis. To try that, you can say x1 equals 1 to 10, the same script that you got. Y1 equals 11, 20, plot x1, y1. Then you say axis 3, 9, 13, 19. So you limit the x-axis between 3 and 9. And the y-axis between 13 and 19. But before you do that, the axis thing, do it without it, then do it with the axis. Like comment it out, then comment it in, and see how is the gradients on the x and y-axis are changing based on that. So here we will plot just as we always plot. You can pay attention. If it's not running with you, please pay attention with the screen here. So that's how we have 1 to 10 on the x-axis. We have 11 to 20 on the y-axis. Now, if we limit 3 to 9 using the axis function, then 13 to 19, and we run it. In this case, you see we started from 3 all the way to 9, and we started on the y-axis from 13 all the way to 19. Where is that helpful? Sometimes you draw a graph, it's very complicated, and you gotta focus or zoom in into a certain point. Then you gotta limit what is the range that you gotta show, and that would be helpful for you in that kind of situations. Now, of course, you can always go back to the default of your axis by writing the word axis auto. Let's say you wanna show a graph for the big picture, like a graph with all details, then you wanna zoom in, so you use the axis function. Then you want to, after that, do something, display some numbers, and zoom out. So you say axis auto, he's going to bring it back to you, starting from 0 to 10, and 0 to 30, and so on. Now, for the subplot, there's a function called subplot. This will show, instead of having one window figure, you're going to see 3 or 4 or 2 window figures. So subplot M, N, and P, you can imagine as having like a kind of matrices or a kind of table. So M and N will tell you how many rows and how many columns, or let's say how many drawings on the y-axis and how many drawings on the x-axis. Then you can say how many items are inside of there by having the word P. So here, after we're gonna execute now the subplot script, you're gonna see graph looking like this. So you have subplot 2, 2, 1. So that's the first graph for a 2 by 2 table or 2 by 2 matrix of graphs. And this is the second one, third, and fourth. Of course, you can clear the figure window in the while we're writing a code in command window. We can say CLC to clear the window. In graph, you can say CLF to clear the current figure window. And CLA will delete all plots and text from the current axes. Now, the subplot script should look like this, and we try to run it. So you have X and Y, you have mesh grid, so it means show me the grid of the XY or XYZ drawing. And this is the function I have, X multiplied by E to the power of minus X squared minus Y squared. Then you say subplot 2, 2, 1 to have the title subplot 2, 2, 1. Subplot 2, 2, 2 with mesh Z means show me the squares. Then he's gonna show you a certain view of how he's gonna look at the graph, the third and the fourth, and so on. So go ahead and load it in your machine. Now let's run it. So as you run it, instead of having one big plot, you're having 4 separate plots. Of course, as a view, each one of them is showing a certain view. And you just made a title. You called MATLAB to tell you to write a title here to do a certain thing, title here, do a certain thing, and so on. Now, for graphical input, you can use open brackets X, Y equals G input. That will help you to select unlimited number of points from the current graph using the mouse or arrow keys. So it's just making you the option, as the mouse is a way to input data to the computer. That's going to give you an option to choose a certain point on the graph. That will be defined as a point in the space X of I and Y of I. Now we can say plot X1, Y1. Right? We know what's going to happen here. Then you say X space Y, close brackets, will equal X and Y, X and Y, X and Y. I can have 5 in this case. So you're gonna let me input my cursor 5 times. That's what should happen. Okay. So I said G input, N in this case, define how many times you want to show points. Now the logarithmic plots, how many of you know the semilog and the log papers? The thing is, you know, when you have those kind of notebooks where they have full of squares for mathematics, so those are considered log because all the squares are similar in size. Semilog, you will find the squares are similar in size in some areas and squeezed together in other areas. So that's called the semilog kind of representation. So you can see here, it's a semilog representation. Sometimes you're having certain applications or drawing a certain graph that needs semilog kind of paper, if you will, or representation. So we can use the command similog of y, open parentheses x comma y. That will plot the y with the log 10 scale, and the x in this case would be a linear scale. Now let's go together and type in x equals 0 to 4 with an increment of 0.01. Then use the similog y x, comma exponent of x, comma grid. In this case, the grid will just give you how does the similog look like, which is those squares. And you can notice the grid for the log is different. It's going to be equal squares, but for the similog, they are non-equal squares. And more specific, the y-axis will be log 10 scale, x-axis will be a linear scale. So x equal 0 to 4, similog x and exponent of x, then you have a grid. And of course, you can add a title and call it similog graph. If you run it, then you get a similog graph with the title showing up, and you can notice how the y-axis is at a log 10 scale and the x-axis as a regular scale. Now, if we comment out the similog, what if we want to draw or graph in a log-log scale? So you can use the word log-log, open parentheses x, comma, exponent of x, then grid. If you run it, that's going to give you the exponent in the log-log scale. What did you guys notice here? Like we draw the exponent of x on a log-log scale and a similog scale, something that the guys in Introduction of Engineering already experienced, but it's good to let you know about that. So you guys know the Cartesian, right? Like the Cartesian coordinates? Yeah? So any coordinates that your math teachers say x and y, this is called Cartesian, right? This is Cartesian coordinates. There is polar coordinates where you are representing everything in a circle. So this is r, and the r is going in an angle called theta. So here we are speaking in the language of x and y, right? We say y equals x to the power of 2 plus 3, then you can represent it here. Here in the polar coordinates, you represent in x equals r cosine theta, y equals r sine theta, that kind of representation. So the x will be represented differently in a circle style. Forget about the circle, we're going to go to it soon. So now this is Cartesian. In Cartesian, if I told you in mathematics course, draw for me the curve of e to the power of x, on the Cartesian, he's going to look like this, right? You studied that in high school. Don't tell me I don't know it. Right? Okay. Now, that's Cartesian is considered log-log scale, like the regular scale, if you imagine. So that's the scale we see all our lives. Now, if we go similog, similog scale was different. Like, if you see the squares, so you get the lines evenly, then they go squeezed together, and so on. So in the similog scale, if you draw what's the graph of e to the power of x, like the function of x equals e to the power of x, he's gonna look like a straight line. So it's like you fabricated the space and time, or the x and y, to show you as a straight line. That's just an information on the side to keep it in your mind, because I feel it's very helpful in many applications in life. Try to draw graphs of x to the power of 2, x to the power of 3, and to the power of 4 over the interval from 0 to 4. So x going from 0 to 4, I can have increment 1, or not increment at all because it's 1 by default. Then I can say similog of x and x to the power of 3. X to the power of 3. Then grid. So just have a dot here. X to the power of 3. And you run it. Now for the polar plots, so we mentioned that there is a polar coordinates versus the Cartesian coordinates. We always used to use Cartesian coordinates. In polar coordinates, instead of having xy, you have theta and r. x would equal r cosine theta, y would equal r sine theta. Of course, the command in MATLAB, you should say polar, open parenthesis, theta, comma, r. And you can try to generate this cool graph by applying x equals 0 to 2 pi with an increment of pi over 40. Then you say polar of x, comma, sine 2x with a grid. That could be very helpful for you in your future career, I believe. So MATLAB is the friend of all engineers because he can handle very well the numbers and matrices. Other coding softwares, you gotta go the long way. You gotta write a lot of code just to do a basic thing, while MATLAB can recognize matrices by default, can recognize how to solve equations, regardless if they are long or short, and knows the Cartesian, knows the polar, knows complex numbers. That's kind of power for the MATLAB to use as engineer. Honestly, you can use it in research, you can use it in the industry, you can use it in a company, you can use it to create any engineering application that you can imagine. Now, for the graph editor, we are plotting something. In this case, we plotted something. You need to know that there is an editor that you can use in those graphs. So if I go to view, then I can go either property editor, or if I go, let's see if it's in file. No, it's in view. Then you go property editor. If you do that, MATLAB will show you the properties of that graph. So those properties can change. You can change the color. So in this case, if you don't want to go with code, of course you can go with code and change the line width, you can change the scale, you can change the limit. But if you want to do it using your mouse, you can adjust the x-axis, y-axis, z-axis, and so on. Now, if you need more properties, just hit on more properties over here. And it's loading longer than anticipated. So you should be able, yeah, there you go. So you can see here what's the labels being used, and you can change them. Like for the title, I can write in here whatever title I want. So I can say XY plot, and it will work in the same way as what it did before in your code. But of course, if you do it in code, maybe it's better. Just one note, I would tell you, MATLAB is not the best way to edit your graph. So generate your graph, take it to Word document, take it to Photoshop, take it to Illustrator, take it anywhere. I don't think it makes sense. Like, let's say I'm writing a scientific paper or doing a project. I wouldn't be playing with MATLAB to make the graph look the way I want it. There is way better softwares that are faster for your time, that you can do those stuff in no time. But again, it's good to know, and I think the beauty of MATLAB, if you can generate for me a plot that will look the way I want it right away, that's amazing. I mean, it's the same line of code, so you can use it all the time. But if you need to go in with your mouse and try to play around, I don't suggest that so much. So again, play around. See, there's here camera tools. There's plot edit tool. So in view, you can add any tool you want. Let's say you have a graph, and you can make an arrow. Again, there's way more softwares that can do that better than MATLAB, like to adding notifications, to add a certain symbol, to write stuff on the graph. Just take it as a GPG and play with it in any other software with more options. Just play with it, see the camera toolbar. Of course, you can change for 3D objects how the camera is looking like and which angle. And you can have plot browser, you can have property editor. You can insert the X label, Y label, and not depending on the code, but like manually. You can have a line, arrow, text, and you can as well have a legend. I think legend is useful. So you can add your legend and change the properties of it as needed. And that's all about graph editor. 3D plots, same as when we said plot XY. Now we say plot 3 XYZ. So you identify X equals 1 to 10, Y to 20 to 40, Z 30 to 100. Then you say plot 3, XYZ, he's gonna draw for you a 3D graph that is in X, Y, and Z axis. Of course, you can use title to define the X and Y and Z axis. You can use label command as well to label those, and title to have a title for the graph, and the same stuff that we used before, you can use it one more time. Go ahead now to generate your first 3D plot in MATLAB. So your 3D plot looks good, you can run it. And now that's your 3D. And remember, you can hold your left arrow on your mouse and be able to imagine how does this line take in his place in the space. So you can imagine this is the x-axis, this is the y-axis, and this is the z-axis. So he's going from 1 and 6 on the x and y-axis, going all the way to what? To 14 or to 15 on the z-axis. That's that. Now, in your textbook, if we comment this and uncomment this, who's taken random numbers for x and y and z to plot a plot for you. Let's do that. So you get this kind of random shape in x and y and z. Just that's something in your textbook, good to know. Now to generate a spiral 3D plot, just uncomment those 3 lines in the script. What we're doing here, we are so we are saying t from 0 to 10 pi, then plot the exponent of minus 0.02 by t multiplied by sine of t, and the exponent of minus 0.0 of t multiplied by cosine of t. If we run that, he's gonna give you a spiral shape. Run it, and you can see you are getting a 3D spiral that's allocating space in the X, Y, and Z axes. Now, animated 3D plots. For animation, one of the functions we use is called Comet3. So that's similar to plot 3, but he create for you animated graphs, if you will, in 3D. And for sure, we have for the 2D version, there is a Comet function that you can use for 2D animation. Now you have here t from 0 to 10, same as the previous function, but instead of having plot 3, we had comet 3. Do that and see what happens with you. If you do that, you'll be able to see an animation for your spiral being drawn in real time. There you go. Anybody see an application for this? Okay, what if we want to do the 2D animation? If Comet 3 is 3D animation, for 2D, that's not in your textbook, by the way, he keep it for you, but that's the command Comet. So if you go X 1 to 4, Y 5 to 8, then you say Comet X and Y, then he's gonna animate it for you. It's gonna be fast animation. Honestly, you're not gonna enjoy it as the 3D. So you can see here, he took like half a second to show you the animation. It depends how big is your data, but this is a small sample of data. That's why it didn't show that quick. I mean, didn't show that slow for you.